Hi, my name is Brian. Welcome to another video on derivatives. In this video, we're going to do some more examples on the chain rule. We do have a couple videos about it, one on the extended power rule and then some other chain rule videos, so go check them out. Anyways, just to recap here, the chain rule is what happens when you have to differentiate a composition of functions, so f of g. So what you're going to do is you're going to differentiate the outside function f, and then you're going to leave the inside alone. So your g is going to be right there. You are then going to then multiply by the derivative of the inside, which is g prime. All right, I'm going to start off with a pretty easy one, but we do have to rewrite it a little bit because people make mistakes when differentiating it. So the derivative of tan squared. The reason people make mistakes is they don't know which one is the outside function. Do you differentiate tangent first, or you deal with the squared? Now this is just a special notation. What this actually means is the tangent, the whole function, squared. So this actually is an extended power rule, still a chain rule though, because that was extended power rule was a special case of the chain rule. But anyways, now it's not that bad to do. So we're going to bring the 2 down. You're going to leave the inside alone. Subtract 1 off the exponent, which is now a 1. So you don't actually have to write that. And then you're going to multiply by the derivative of the inside. Derivative of tangent is secant squared. All right, let's try another example. The derivative of secant x to the 1/3 power. Now here, we know that the derivative of secant is secant x tangent x. When you differentiate it when the inside is another function, you're still going to write secant tangent, leave parentheses on both of them, and then that's the derivative of secant. You are then going to rewrite the inside function. You're going to leave it alone, like that. And then you're going to multiply by the derivative of x to the 1/3, which is 1/3 x to the negative 2/3. A big mistake on these is people forget to put the x to the 1/3 with the secant, and they only do it with the tangent. All right, let's try one with a quotient rule. Let's differentiate 4x plus 1 squared over, well, let's actually do tangent squared x. Now, if this is the problem that's given to you, you should go and rewrite this function so that tangent is written in this form here. I'm going to do that right now. That's tan x squared. So obviously I'm going to have a chain rule. I'm going to have one here and I'm going to have one here. But the whole function is a quotient of the top and the bottom piece. And so we're going to have to start off with the quotient rule. I'm going to call this function up here f, and then I'll call this one g. The quotient rule is f prime g minus fg prime all over g squared. You can also remember it by the low d high, which I'm going to put up there. So you'll have the low d high minus high d low over low squared. Okay, so I'm going to rewrite this, but I'm going to put in all the specifics here. So f prime, so that's the 4x plus 1 squared prime. I'm going to leave g alone, so that's tan squared, minus, then I'm going to leave f alone and differentiate g. So I'm going to rewrite it in that form now, the little prime. And this is all going to be over the bottom squared. So that's going to be tangent x squared all squared. So you can see now when it's time to differentiate some of the pieces, in this case we're going to have a chain rule, and over here we also have a chain rule. Okay. Derivative of this piece. So it's an extended power rule, so you're going to bring the 2 down, leave the inside alone, subtract 1 off the exponent, and then multiply by the derivative of the inside. Derivative of 4x plus 1 is just 4. Okay, so that's my f prime. We're going to leave g alone. Minus, okay, leave f alone. Derivative of tan squared, that will be the 2. All right, leave tangent alone. Subtract 1 off the exponent, you get 1. And then differentiate tangent, which is secant squared. So there's my g prime. And this is all over. Now tangent squared is now tangent to the 4th. So as you can see, when taking derivatives that involve a combination of the derivatives, the chain, in this case it was a quotient with a chain, these can get pretty big. So make sure you practice a lot, take a look at some of our other videos. Hope this helps. Good luck. Bye.